Although you may have seen the grid view and list view controls in other programming environments, it's unlikely you've ever worked with the semantic zoom control, which is new for Metro-style applications. This control provides a way to manage and present two semantic views or abstractions. It's not about zooming in physically, it's about logically zooming in on data. It uses a single set of hierarchical data or content and displays it in multiple views. This might be something like the folder structure of a computer, where at one level you see the names of the folders, at another level you drill down and see the contents of those folders. A library of documents, where you might group the documents by category or by first letter of the name, and then you can drill down and see the individual items within a given category or first letter of the name. Or a photo album, where you group items by date, and then you can drill in and see all the items for a specific date. And here you have one view, for example, where we see decades on a list, and then by drilling in, we can see individual years within that decade, and maybe drilling in again, we could see months within individual years. Microsoft has provided a nice example that demonstrates using the semantic zoom control, which, by the way, is what they use on the desktop. Let me go over there and show you that real fast. If I go to my desktop, I should be able to scroll out, and here I get an overall view of my desktop. This is a semantic zoom view where I can see everything. I can select an item, and then that item becomes selected, and we zoom back out to that area. For example, if I want to go here, I have blend, I click on that, and now that area of my desktop becomes clear. Let's try it again. I can go back over here, and I'm back at the first portion of my desktop. In any case, that semantic zoom allows us to build our own applications as well that do this sort of thing. Let's take a look at Microsoft's example that does just this. I've loaded Microsoft's sample application, which demonstrates grid view grouping, a necessary feature for building semantic zoom controls, and a semantic zoom sample. In the first scenario, we're creating a grouped grid view based on the category of each item in the data collection. You can see we can scroll across, and they're grouped by item category. Here I can group a different way. I'll group by first letter of the item name, all the B's together, the C's together, the F's together, and so on. And finally, given that layout, I can create a simple semantic zoom. Here's my data, grouped by first letter of the item name, and I can switch views by clicking this button, which switches us to our outer zoom, which I can then click a letter and go back into our inner zoom. I can get that same behavior by pinching on the screen if I have a touch screen, or using Control and the mouse wheel to zoom out and click a letter to zoom back in. So our goal is to examine the code here to see how this example is working. Remember, as we talk about things, the first example groups by the category name. The second example groups by the first letter of the alphabet of each item, and the third example creates a semantic zoom which has two views, and the two views are really two different layouts. One here is a grid view, and the other is a templated layout which allows you to display only the first letters, and clicking one will take you to where you need to go. You need to lay out the two layouts, that is this and that. What happens automatically because of the semantic zoom is clicking on an item automatically zooms you into the correct place on the other layout. Let's stop and look at how this code works. Go back to our desktop and allow Visual Studio to stop running. We'll look at scenario output 1.xaml. This is the one that shows us a grid view grouped by the category. Here's our grid view, and you'll notice first of all that in this example we aren't setting properties that refer to resources elsewhere. Here the items panel is defined in line and the item template is defined inline, just another way to get to the exact same behavior. Now, I'm not too concerned about the actual layout here. What I'm mostly concerned about is where is this data coming from? All right, well, first of all, if we look at the item source for our grid view, named items by category, you'll see that the item source is set differently here than in examples you've seen previously. Previously, we've set this item source property in code, and that still works. You can always do it. But if you want to set it declaratively at design time, you can also use the binding keyword to say, I'd like to bind the item source to some data structure. If you're going to do that, you need to set up a resource that represents that data structure. We'll set source equals, and we'll get the data from a static resource named CVS1. Let's go find CVS1. Here it is. It's a collection view source, an object which allows you to define a collection as a view source, and its name is CVS1, and is the source grouped is true. So somewhere, someone needs to define what that collection view source actually is. It's certainly not here. All this stuff is defining the markup, which is the layout for our grid view. Let's look at the code for this page. Here in the code, you'll see that we have an instance of the store data class, which we've already seen, named _store_data and is defined as null. But in the constructor for this page, we have code which creates a new instance of store data and places it in there. And now we create a list of group info list of object. That is, a group info list is a grouped set of data called data category, and we call a procedure get groups by category from that store data instance. As you can probably guess, this code creates a data structure that has hierarchical data. It has a collection of categories, and within each category is a collection of items in that category. Let's go find this code. Here we are. The get groups by category returns a list where each item in the list is a group info list of object. Well, where is that defined? If I right-click on it and choose Go to Definition, you'll see that a group info list has a key and an enumerator. So it's basically a collection of objects, and it's based on a list of objects. So let's go back a second. I don't want to go too deep into what we're looking at here. So we have a list which contains, as each of its items, a collection of items. So we need to create that, and we do a query here which retrieves from item in collection, order by the category of each item, group by category into a collection called G, and select a new output, which is a group name and the items. So you can see that what we're getting here is a collection which contains the group name and all the items of that group. We'll create a new group info list, set the key to be the group name, and for each item in the collection of items in that category, add them to the info property. When we're done, we add to our groups collection that info, and we end up with a collection of one type of gelato or whatever. With all of the items that are gelato, we get sorbets, and all the items that are sorbets, we get frozen yogurts, and all the items that are frozen yogurts. So that's how we generate the data that we store into our data category, and we assign that as the source of CVS1. Remember CVS1? It was defined out here. So the source for this collection view source is a grouped data source which has items by category. Given that collection view source, which is grouped, we can then set it as the data source for our grid view. The grid view then can retrieve items and display them correctly. We have an item template which defines what each item should look like, and you can see that for each item we have a lot of property set including a style. But within there we have an image. And where's the image coming from? You can see the image has its source set to the image property of the data that is filling this grid. There's a text block, and in the text block you can see that its text is bound to the title of every item filling this grid. There's also a group style, and this allows you to define what the group header looks like. It is a grid containing a text block where the text is bound to the key property of the item filling this grid. So if we run this again, you'll see we have the groups here where each item has a template that defines how it looks. We have an image and text, and the group header is coming from that key property which was built into the complex data structure that we built as part of the code in the data store, or the store data class. All right, let's go back and look at the next example, which now groups by first letter of each item in the store. This would be in scenario output 2. Let's get that one up. This one is laid out much the same. You can see there's an items panel for the items, an item template. There's a group style that defines the group header, and again, it's bound to the key, but I'm guessing the key is something different this time because we're only using the first letter of each group of items. We have a collection view source named CVS2, which is grouped. Let's see how that gets filled in. Here in our code behind, you'll see this time we're doing the exact same thing. We're setting the source of CVS2 to be data letter, which is defined as a list of group info list of object. We get it by calling get groups by letter. And I'm guessing this works pretty much the same. If we go to the definition of get groups by letter, this time we're using title character 0 as the item to group by. Of course, this counts on the first letter all being uppercase, and I guess they are, so it'll group them not by case, but individually by letter, like B, G, F, and so on. And we get the group name to be the key, and the items to be all the items that start with a certain letter, because we've grouped by that first letter. Then again, we put into the key property the group name, which will be the first letter, B, G, F, R, M, or whatever. And we'll copy each of the items that start with that letter into a collection, and then add the whole mess into our collection of groups. And we return that collection of groups. This time, we end up with the same data grouped by the first letter of each item in the group. What this example proves is you can group by a number of different things using the same data. Now the question is, how do we create this? Well, clearly, the semantic zoom must contain the layout for two different, layouts. We have this one, and we have this one. They handle the animation between the two. They handle selecting an item, but you need to supply the two layouts. As you can see in this layout, we have an image and text in a stack panel in a tile. That tile is a little larger than the stack panel with some gray content around it. Well, let's go look at the code to see how the semantic zoom control works. Let's look at scenario output 3. And in this case, the first thing you'll see is we're using the same view source as we used in the last one. Now, you can't tell that by looking at this, but I'm guessing because they named it the same thing, that it is the same thing. Let's go look and make sure. Yep, looks like it's set up pretty much the same way, except we have one more line of code. Let me come back to that in a moment. These two lines of code are exactly the same as in the previous example, where we're grouping by the first letter. Notice that here, let me get a little more real estate on the screen. Here we have a semantic zoom control. Leave that alone for right now. But within there, we have a zoomed out view property, which contains a grid view. And this grid view should look awfully familiar. It's exactly the same grid view we just looked at. It may be modified slightly, but it's the same concept. So rule number one, when creating a semantic zoom, you need to lay out each of the two views individually. Get them working. Each of them is completely independent. So here is a grid view control, which we created in the previous example. Here is a grid view which represents the selected first letters, and this is a grid view that had to be laid out as well, and that is the zoomed in view. And I'm guessing this actually is the one we looked at in the previous example. I'm not being careful here. This is the view that we looked at in the previous example, and as you'll see, all we do is supply the two grid views, one for zoomed out, one for zoomed in, is in the semantic zoom.zoomed-out view property and the semantic zoom.zoomed-in view property. If this grid view represents what we saw in the previous example, this grid view must be the one we see when we zoom out, that is the letters. Let's see what this looks like. When we zoom out, we'll see a grid view which contains as its item template a data template which is a simple text block. The text block contains text which is bound to the group.key value. Remember what the key was? It was the first letter of each group's name. So that will be just the A, B, C, D, whatever. The font family is set, the font size is big, the foreground is black. There's an items panel, which is a panel template, which gives us a wrap grid, which has one row. And that's why we see it in one single row across the screen. We see the item container style has a margin of 4, a padding of 10, border brush is gray, etc. That's what we see around each of the items in this grid view. And that's the entire grid view. So that defines the content for the zoomed out view. And for the zoomed in view, this is the grid view we saw in the previous example. I won't go through all the details again, but remember the basic concept is you see a stack panel that's horizontal, where each item contains an image and a text block that describes the particular store data item. You can see the binding for the item source for this grid is CVS2, and for this grid, there it is, for this grid, there's no data source specified. Well, that's interesting because it's definitely getting data from somewhere. Remember, there was one line of code in the code behind class. I said we'll look at it in a moment. Let's go find that. Here is that third line of code, and what does that do? That sets the item source property of the zoomed out view, and look what they've done. They don't really have a name for it. I guess they could have supplied a name, but they didn't. It is the zoomed out view property of the semantic zoom cast as a list view base class. We'll set the item source property of that to be cvs2.view.collection groups. That's a property of the view of our collection view source that allows us to get at just the high level collection, that is the letters of the grouped items. This requires a little bit of study, but you've seen in this example how you can create the semantic zoom by creating two layouts. One for the zoomed in view, one for the zoomed out view. We created the zoomed in view individually as part of our demo. The zoomed out view was a separate view which somebody at Microsoft created separately, but you would need to also create the zoomed out view and test it before you place it into this property. So the rules would be create your two views, get them working, and then place them inside the zoomed in view and zoomed out views of your semantic zoom control. It's a little complicated, but it gives great effect within Metro style applications.